Welcome back to our class today. We are going to continue from where we stopped in the last class. This is exercise 1B. Our goal now is to solve some of these exercises. So what I will do, I'll take the ones I think are like the tough ones, then I'll leave the rest out. I'm taking from number 11 to number 15. Now, what they want us to do? They say simplify the following by making the number under the square root sign as small as possible. Remember the last class where we solved this? The main aim of simplification is to make sure that the number under the square root is the smallest irrational root you can get while the perfect square comes out. So I'm going to start from number 11, start by number 16, maybe 15, while you can on your own do the rest. So let's start. So let's start from number 11. We have root 99. So what we have to do is to find the perfect square inside this and then factorize it further. So let me just show full work so you understand. If you don't know, perfect squares are the numbers I've explained in the previous class that have a rational root. Numbers like 4, the square root of 4 is 2, 9, the square root of 9 is 3, 16, the square root of 16 is 4, 25, the square root of 25 is 5, and so on and so forth. So now, this is 99. Let's assume you're a layman that doesn't even understand the factors and make up this 99. What you're going to do is this. You just factorize it using the normal factorization method. What's the smallest number that can divide? 3. When 3 divide 9 gives you 3. When 3 divide by 9 again gives you 3. So the next thing is 3. When 3 divide 1, when 3 divide 1, the smallest number that can divide 11 is 11 because 11 is a prime number. So you get 1. So here now, 99 makes, what makes up 99 is 3 times 3 times 11. And we all know that 3 times 3 is 9, which is equal to 9 times 11. Now 9 is a perfect square. So this is our target. We can now say square root of 99 is the same thing as square root of 9 times square root of 11. For those that don't understand this rule, this rule means that let me explain it because we did it in our last class. It means that 99, that's 9 times 11, can also be expressed as square root of 9 times square root of 11. So that's what I did. So we explained this in the last class. I'll try and put the link to this explanation in the description of this video so you can go through it and understand the rule. So let's go. So the square root of 9 already is 3 times square root of 11, and 11 square root is already an irrational number, so we are going to stop it here. So our final answer is 3 root 11. This is our final answer. So let's go to the next one. I might start jumping steps. I might not have to go through this process. This is why I'm doing it for those that don't know how we come about the two factors that are multiplying the number. So for this number 12, I will have to jump to step. This 150 is the same thing as square root of 25 times 6. If you're wondering how we come about this, you just simply find it. This is 25 is a perfect square. That is the target of this class. Get the perfect square so that you can factorize it outside the root. So how do we get this? It's as simple as we did the former one. Let me just, for the sake of that, let me solve this. But going forward, I will not have to show the full example. This is 150. You can just say, okay, 2 go here. 2 divided by 15, you have 7. You take 1 here, 10. 2 divided by 10, 5. That's 75. What's the smallest number that can go? 3. 3 divided here, you have 2. Take 1 here, 15. 3 divided by 15, 5. So we've gotten the 25, which is our main target, a perfect root, a perfect square, I mean to say. So you can just say 25, 1. So 2 times 3 is 6. So you can just say 6 times 25. That's how I come about this. So going forward, I might not need to show the full working again, but just know that the main aim is to get the factors of 150, and inside the factor get a perfect square, then take out the perfect square and leave the rest inside the root. So this is equal to 25 square root of 25 times square root of 6. Now so square root of 25 is 5, so you have 5 times square root of 6, which is the same as 5 root 6. This is our final answer for this second one. You can also cross-check it. If you have the textbook, you can check the answer section. For this is equal to square root of 49 times 2. 49 is a perfect square, so we have is equal to square root of 49 times square root of 2. So we continue from here. That's equal to 7 times square root of 2. So final answer is 7 root 2. Please take note. You can see that the number we have inside the square root, the root sign, is the smallest non-rational number that can be there. You understand? There's some of them that you will solve. You still have something maybe that can still be factorized further. In that case, you have not fully simplified your answer. So you have to make sure that your simplification goes to the last point of it before you can say, okay, the simplification is done. So what I said here, I will explain it here. Now, this 288 is the same thing as square root of 144 times 2. Now, 144 is a perfect square because 12 times 12 is 144. So that's why I have to single it out and leave the 2. So it's equal to 144 square root times square root of 2. My final answer is 12 root 2. Now, this is the final answer because this 2 is the least non-rational number that can be inside the square root. But let's say someone solves something like this. This 208 can also be expressed as this. Can also be expressed as 8 times 36. Now you can see that 36 is a perfect square. So which will give you square root of 36 times square root of 8, which will give you 6 root 8. Now, this is a wrong answer because why? 8 can also be factorized further. So if you are solving simplification of surd, make sure that you are getting the least of the least of the least before you can say, okay, this is the final simplification. So I want us to take note of that while we go through this class. So the final question is 147, which is still equal to 3 times 49. 49 is a perfect square. So this is equal to 49 square root times square root of 3. Please, I know I'm interchanging this. It's still the same. I think I did it somewhere here. 144. Okay, I did it here. When you interchange it, it's still the same. 2 times 3 is 6. 3 times 2 is still 6. So let's not get confused because of that. So then the next is 7 root 3. This is the final answer. So this is the exercise 1B, and this is where we're going to stop for today. Thank you.